Hello and welcome back to the part 3, the final part of the Geodict 2021 visualization workshop. In part 1, we learned how we can visualize gray value images, or rather volume images, as well as voxelized microstructures. In part 2, we learned how we can visualize simulation results alongside the input microstructure. We learned about additional volume field visualization features, in this case the streamlines, and what is possible with the GeoApp Easy Image. In both parts, we ended up with still images. Now in this upcoming part 3, we would like to show you how you can produce nice looking videos and animations in Geodict as well. We pick up right where we left off and dive right back into Geodict. In this part, for a change, we will actually load a different microstructure with another simulation. In this case, it is not just a pure flow simulation, but the result of a FilterDict run. FilterDict is our filter simulation module, which works with simulating fluid flow through a microstructure and then evacuating particles along with the flow. These particles can then interact with the filter structure and get either stuck in the filter structure due to mechanical reasons or electrostatic attraction, for example. Or they can make it through to the other side. We are going to look at the so-called FilterDict lifetime simulation, which estimates the lifetime of a filter. To account for the fact that the filter gradually clocks over time, FilterDict lifetime uses an iterative approach. First, a flow field is simulated for the clean filter medium. Then a so-called batch, a subset of the simulated particle, is injected into the filter medium. Some particles will get stuck inside the medium and clog the filter. Then for the partially clogged filter, the flow field gets recomputed and the next batch of particles will be injected. This process is what we are going to visualize here. To begin, we are going to load the result file, the .gdr file, for the simulation run by clicking on the open.gdr icon up here in the toolbar. We navigate into the subfolder, part 3, and double-click the filter lifetime singlepass.gdr to open it. This again opens the result viewer that shows us the result of this FilterDict simulation. Again, next to the report subtab in the result tab here, we also have the plot subtab that shows us two important information which characterizes the filter behavior over time. First of all, there is the pressure drop over time. Due to the fact that in this simulation we have assumed a constant flow rate, and because the filter gets clogged over time, we can see that the pressure required to maintain this flow rate increases more and more. This is also what signifies the lifetime of a filter, because usually it becomes unusable once a certain pressure drop is reached. In the other plot we can see the deposited particles over time, which is the amount of particles that is clogging the filter as the simulation progresses. These plots can also be easily saved as images by right-clicking in the plot and selecting Save Image. We give our plot a name, maybe my plot, and save it in the current resolution with a click on OK. The save location is of course our project folder, where we can quickly find our plot. We navigate to our project folder and open the saved image of our plot. We see that it has been saved in a resolution as is expected in the result viewer. We close the image and our project folder again and go back to the result viewer. What we want to do now is go to the Create Videos tab up here. What we can already see here is a small preview of one of the template videos that we provided with Geodict. Select Deposited Particles Video from the drop-down menu here if it is not already selected. Then click the Edit Parameters button here. For the particle rendering parameters, choose particles from the drop-down list. The rest of the parameters we can leave as they are. The video will be 5 seconds long. The font size of the plot is 14. The plot will be positioned on the left side with a 500 by 500 pixel resolution. We click OK to accept the input. Now we click on Create Video down here. Geodict asks if we should overwrite the already existing file since the video is already in the workshop materials. I want to overwrite the video and click yes. Since the video generation takes some time, you can also watch the already generated video to follow the workshop. As you might have noticed before, there is still a small bug left in this current version of Geodict, which renders the dialog a bit too small. We extend the dialog till we can fully read the text and see the OK button. Here we have some information about the video we are about to create. We click OK. Now Geodict generates the video. Geodict will eventually ask if we want to overwrite the already existing intermediate results. Here we can press overwrite. The video generation will take some time and I will fast forward the workshop recording again to show you the result. After Geodict has finished, we click OK, and in order to play our video, we can click on the play video button down here. In case this doesn't work, open your project folder and manually start the video. What we can see now in the video is a 3D visualization of our filter media with the animated filter simulation process, namely how the filter gets clocked over time by the particles. In the center of the video we have our filter media, created from two different fiber types with different diameters, in red and in green. The particles build up at the inlet of the filter. The green particles are the ones of the current batch. The gray particles are the ones of the previous batches, which have been filtered and added as obstacles to the filter geometry. On the left hand side you can see an animated plot with the deposited particle volume for each z coordinate. Z is in this case the flow direction. The flow happens from top to bottom, which is the z-axis. We can see in the plot the gray curve increasing, which signifies for each depth inside the filter medium, starting from 0 at the top down to 500 at the bottom, how much particles have been accumulated in this slice. The horizontal line signifies the actual start and end of the filter medium geometry inside the domain. We can see that there's an initial empty inlet region at the top and also an empty outlet region at the bottom. Those regions in 3D space correspond to these areas here in the plot. We can see in this case we have a fairly poor filter medium for this type of particles, since they get immediately stuck on the top of the filter medium and form a so-called filter cake. The rest of the filter media is practically unused and unnecessary in this case. Only a few particles penetrate slightly into the filter medium, as we can also see in the plot here. And no particles make it through to the other side. Now let's go back to Geodict and the result viewer. For many of the built-in solvers, Geodict ships with several of these video templates, which are directly selectable via the result viewer. That allows us to quickly generate nice-looking, comparable videos. But Geodict also makes it easy to create totally custom videos in the video dialog editor. We will have a look at that next. First, we close the result viewer window, down here. And since the template for the video that we just ran had to actually load the data into Geodict to produce the single images, the data is still loaded. To save some time in this part and to concentrate more on the process of video creation, we ship the workshop materials with an already set up visualization settings file. In order to load it, open the visualization settings with the double arrows over here, if not already open, and click on the load icon over here. Then navigate to the part 3 subfolder and open the file part3.visualizationsetup.py by double clicking. This gives us some nice default rendering settings, again having the base visualization principles in mind on what we want to highlight and how to achieve a good and readable image. Next, we open up the video dialog via the menu, File, Save Video As, or via the icon in the toolbar over here. When we open the video dialog the first time during a Geodict session, the animated thumbnails are generated first. This takes a few seconds. The video dialog contains a selection of preset animations with animated thumbnails as preview. For example, we can see several videos with animated clipping in different directions. Flyby animations, particle animations, rotations around the main axis, and also a Streamlit visualization. Every video can be quickly created from the preset by choosing Generate Video. However, it should be noted that the necessary data, for example for the particle animations, must be available and loaded. Each video preset can also be opened and edited in the video dialog editor by clicking on the Open Video Editor button. For our video that we are about to create, we will use the Clipping X video preset as our starting point. We select the preset Clipping X and click Open Video Editor. The video editor in Geodict is a graph editor or a visual editor. We maximize the video editor. The video editor consists of 3 different panels. If any of those sections is not being displayed, move your mouse over the vertically arranged dots at the far right or left side of the video editor. The mouse will indicate the right position by changing the mouse symbol to 2 arrows pointing away from each other. Left click and hold the mouse button and move your mouse to the middle of the video editor till a blue line appears in the graph section. This indicates that the section will be visible after the release of the mouse button. Release the mouse button and the panel will be visible. I will start explaining the video editor in detail by going from left to right. In the parameters panel here, we already have the visualization parameters that are currently used and animated. Unfortunately, there is a bug still present in this version of Geodict, which adds more parameters that are not actually used. We will remove them except the upper 2 parameters, box clipping start and box clipping end. To remove a parameter, we right click on the parameter and choose Remove from the right click dialog. We do this for all these parameters now. The long names of the parameters are also the path of the parameters in Geodict's GeoPython structure and the visualization settings here. The box on the left side of the name shows the visibility of the parameters in the graph panel. A checked box means visible, an unchecked box means hidden. If the parameter has a little black arrow on the far left side, it means that the parameter has subparameters, in this case for the box clipping, the different axes in which we can clip. To expand them, we click on the arrow. To hide them again, click on the arrow again. We can highlight the parameters in the graph panel to see its course and change of values over time by clicking on the parameter. The selected property will be highlighted in red in the graph panel. The center panel shows the graph editor. It displays the flow and change of the visualization parameters during the video on an X and Y graph. The x-axis shows the time in frames and the y-axis shows the change of values of the visualization parameters. The curves are showing the change of the parameters over time between 2 different points, the keyframes. A keyframe is a frame or position in time used to indicate the beginning or end of a change made to a parameter. A parameter control point is a representation of a parameter on a keyframe, which holds the current state of the parameter on this keyframe. At the top of the graph section, we have a toolbar. From left to right, we have Undo to undo an action, Redo to redo an undone action. Center View will zoom in or out of the graph section so that everything that is visible is in view. Zoom in and zoom out, the play button, that will play back the animation in the graph panel from the first keyframe to the last keyframe and will then loop. The animation will also play back in the Geodict visualization area. The position of the animation will be displayed by a vertical green line that moves along the x-axis, a so-called playhead. It can be set manually by clicking in the graph panel or on the x-axis. This will also update Geodict's visualization area. Next, we have the graph panel itself. Here we can modify, create, delete and capture keyframes and points. I will start with how to navigate in the graph panel. To zoom in and out, use the mouse wheel while the mouse is inside the graph panel. The zoom takes the mouse pointer as its center and will zoom in and out of its position in the graph panel. To move around the view, right click and move the mouse inside the graph panel. If we only want to affect one axis, hover the mouse over the value range of the axis and use the mouse wheel to zoom or the right click to move just on this axis. We center the view back by clicking the Center View button. Next, we have a look at the keyframes. On the x-axis, which represents the time in frames, we have markers at frame 0, 120, 240 and 360. Those markers are keyframes and are displayed by a small dark gray box on the x-axis and a dark gray line in the graph panel. Keyframes are groups in which the parameter control points are living in. Those are represented by a small blue box on the keyframe lines. A keyframe can be selected by left-clicking on the small dark gray box on the x-axis. By left-clicking and holding, we can change the position in time of the keyframe by moving the mouse left or right. To remove a keyframe, we can right-click the keyframe handle on the x-axis to call its options menu and select Remove Group. To select the control point of a parameter on a keyframe, we left-click on the blue box or red box, which represents the point. The control point will show up in the value panel with its name, position, value and interpolation type. With this point selected, we will have a quick look at the last panel, the value panel, here on the far right side of the video editor. The value panel handles the values of keyframes and points and lets us modify them via direct input. In our case, with this point selected, we see its name, position in frames, the current value and its type of interpolation. Let's have a closer look at the interpolation types. There are linear interpolation of values between 2 points, the one selected and the next one. There we have also constant. The values of a point will be constant till a new point is reached. And we have smooth. The values between the selected and the next point will be calculated for a smooth transition. If multiple points are selected, the value panel will display different options that can be modified based on the context of the points. If multiple points on the same keyframe have been selected, the value panel displays for name, multiple selected. All points share the same position since they share the same keyframe. If the position is changed, all selected points will be modified. If the points have the same interpolation applied, the interpolation will show the specific interpolation type. Else, it will show the type mixed. Changing the interpolation type will apply to all selected points. If multiple points have been selected on a different keyframe, only the interpolation type can be changed. We start by saving our current video editor state by using the now well-known dialog Save and Load buttons down here. We click on the Save button, enter a good name and save it. I recommend to save your work regularly. Before we start, let's take a look at the video we saw at the beginning and see what parameters we need to animate in order to recreate it. The finished video has already been delivered with the workshop materials for viewing. We open the project folder, navigate to the subfolder Part 3, then again to the subfolder Finished and double-click the video Part 3 Final Video MP4 to have a look at it. We see our filter media rotating around its z-axis as it is cut in the x direction. During this process, the particle deposition is also animated. What we need now are the parameters for the rotation around the z-axis and the playback of the particles. The clipping is already done by our preset. We first add the rotation around the z-axis. We close the video again and go back to Geodict and directly to the video editor. To add a new parameter to animate, we right-click in the parameter panel. Alternatively, you will find the same option to add a parameter in the menu by clicking on Properties, Add Property. We add another parameter now by right-clicking in the Parameters panel and choosing Camera 3D, Local Rotation. As already mentioned in Part 1, this is the other way to control camera rotation, not via heading, attitude and bank, but by rotating the local axis of the domain. We unfold the added local rotation parameter using the small black arrow and uncheck X and Y. Additionally, we uncheck the two box clipping parameters to get a better overview in the graph panel. We now see that there are no more points and curves in the graph panel. We now have to add the control point for the parameter on the keyframes ourselves. Since we want to do a full rotation on the z-axis over the whole time, we only need 2 control points. One at the beginning with the value of 0 and one at the end with the value of 359, which gives us a nice seamless rotation that is great for looping. We add a new point to the keyframe at frame 0. To do this, we right-click on the keyframe and select Add Point Local Rotation Z. A new control point should appear here. We do the same for the keyframe at frame 360, right-click, Add Point Local Rotation Z. We select the control point on frame 360 over here and look at its value in the value panel. We change the value from 0 to 359 and recenter the view to keep the point in view. Next, we select the keyframe 360 and move it one frame to the left to frame 359. This way we have a 1 degree change per frame on a perfect rotation loop. We save our intermediate result down here as My Video Dialog 1. Then we minimize the video editor, drag it a bit smaller and move it to the side so that we can see the visualization area better. In the video editor, we click on play and look at our current result. As we can see, we have a nice rotation around the z-axis while our filter media gets cut in an interesting way. The particles keep their current state during the playback. We stop the playback and see how we can animate the particles next. We will use the video editor's automatic detection system, which recognizes when values have changed but are not selected as parameters. First, we have to change the desired value, in our case the batches, to trigger the recognition. To do this, we switch to the particles tab if we are not already there and change the value of batch like this. Then we maximize the video dialog again and zoom a bit out and move the graph panel so we can see further to the right of the last keyframe at 359. Still to the right of the last keyframe over here, we right click in the graph panel. From the menu we select Pull Keyframe from Geodict. The tracker dialog appears and lets us select which parameters we want to add that have changed recently but are not listed in our parameter panel. We select the particle batches. The particle time parameter has no meaning for our data because we have no particle movement stored in our data, only the end positions. We click OK. We have to open up the video editor again. In our parameters we now have the particle batches. We select the batch parameter in the parameters panel. By highlighting we can see at which position the batches are animated and how. Additionally, we see that a new keyframe has been added to our animation, which we will delete later. First, we select the first control point of the batches, here at keyframe 359, and drag it to the keyframe 0. If we drag the control point close enough to a keyframe, it will automatically snap to it. We let go and see in the value panel that this control point is now at position 0. In the UI, the batches start at index 1. If you control them with Python or the video editor, we have to start at index 0. We set the value of this first batch point to 0. Now we select the second control point of batches and drag it to the keyframe 359. We change the value to 13, not 14. As just mentioned, we subtract 1 here because of the index starting at 0. Now we delete the keyframe after keyframe 359. We right click on the handle here above and select Remove Group. We save our intermediate result again as My Video Dialog 2. We minimize the video editor again and move it to the side to get a view of the visualization area and play our animation. We have now recreated the animation pretty accurately. The last thing missing is the starting position and rotation of the camera. If we move and rotate the camera while the animation is playing, the animation continues to play, but with the new camera setting. This can be done to quickly adjust a saved video to a new structure, but it makes it difficult to repeat the process again. We would like to define the camera settings so that we can create exactly the same video again. To do this, we stop the playback and maximize the video editor again. By right-clicking in the parameters panel, we add the parameters camera, camera 3D, translation, and camera, camera 3D, rotation. Since we already moved the camera back and forth, we lost the original values for rotation and translation. To get them back, we reload the visualization settings from the beginning of this part. We minimize the video editor and load the visualization settings again over here. As a reminder, here in the subfolder part 3, choose the file part3 visualizationsetup.py. As we can see in the visualization area, we have successfully loaded our settings. We maximize the video dialog, and here we right-click again behind frame 359 and select Pull Keyframe from Geodict. If the tracker dialog comes up again, just select nothing, click OK, and go back to the video editor. We hide the newly added rotation and translation parameters. If other parameters except rotation and translation are hidden, we unhide them to make sure we can select them. We use the box selection to select all other remaining control points on the new keyframe. With a right click on one of the selected control points, we select Remove Points. We make the parameters translation and rotation visible again and move the keyframe on which the remaining control points are located to frame 0. We zoom in a little bit to make sure that we have hit frame 0 and readjust if necessary. When we are ready, we can now move the keyframe 0 to the side, again as a control, and see that both keyframes have been merged. We make sure that everything is back in place on frame 0 and center our view. For the parameters translation and rotation, we now only have the control point on keyframe 0, which means for Geodict that it will always set these parameters to these values. We can test this by replaying the animation, moving the video editor aside and rotating the camera in the visualization area. We see that we can move the camera initially, but Geodict will always set it back to the given position. We can do the same with other parameters that we want to be hard-coded into the video and not to be changed. Now that our video is finished, we want to save it as a video. We bring back the video dialog and stop the playback. Before we generate our video, we save our final result here as My Video Dialog and add final to the name. Then we click on Save. And we can now share our result with colleagues and reuse it for similar structures and simulations. To generate the video, we select from the video editor menu, Generate Video. In the Save Video dialog, we can choose between different video formats. We leave it at the default setting MP4, which generates videos in very good quality and a relatively small file size. For frames per second, we select 30. With our video dialog, this will create a video with a length of 12 seconds. The image resolution is left at Full HD. As a marketing employee and designer, I advise you to select Keep Images. This will save the single frames as PNGs, uncompressed, and can be used for later video editing. Finally, we have the option Unroll as Python. This does not generate a video, but saves a Python file in which every setting is stored for every frame. This can be useful if you want to perform your own operations in addition to each frame. For example, similar to the result viewer presets, if you want to compose a graph into the images. We will only create a video here and now. We click on Run. We name our video My First Video Dialog Creation and click Save. The video generation will now take some time, about 5 to 10 minutes, depending on the hardware. I will fast forward the video for this workshop and present the result. The video generation is now finished and I will now open the video in the project folder. As we can see, we got exactly the same video that we could already see in the preview in Geodict. We have a nice 360-degree rotation of our filter medium, while the cut shows us the inside and the particles settle in the filter medium. The entire scene visualized in style and corporate design compliant, at least for us at Mass2Market. Now it is up to you to present your work and your company just as elegantly. This concludes part 3 of the workshop, in which we learned about the possibilities to generate videos in Geodict. We got to know and applied the video templates in the result viewer and created our own video in the video dialog based on a template. As a result, we got 2 impressive videos. And that also ends this visualization workshop. I hope we were able to offer you extensive insights into the possibilities Geodict offers to present your work and results in an impressive way in image and video form. We know that after such an intensive workshop, not all information can be remembered. Therefore, this workshop will be available for download shortly after the user meeting. Afterwards, there will be a question and answer session for all those who want to. For all the others, I will say goodbye. Thank you for your interest, and I hope you enjoy the other presentations and workshops at this year's digital user meeting. See you again.